In this video, I'm going to be going over the structure of the class activity 5 and the solutions for it. As you kind of already gone through this, just to understand design logic and game conditions. Like I mentioned in this class activity, there are about 3 tasks here, and the last one task 7 I went through in class that finished off our code with me to part 3. And so now I'm just going to go with you through these 3 different tasks just to help you understand the structure of getting a scenario in computer science and actually using that to code. And so that's what we're going to be going over today. I also provided you with a test case PDF that we'll kind of go over in the next section here, and then we'll go through the code. So when you download that PDF, you'll see the instructions here along with some pseudocode and test cases that you can use to kind of guide you. Pseudocode is kind of what we want to use in order to kind of pull out the necessities and the importance and the functionality of the system before you actually code. Now, it's always good to kind of pre-plan what you're going to do before you just go and do it for efficiency's sake. However, this is just us learning this process now. So just take your time and go through it. All right, in the next section, we'll go over the actual coding for it. All right, now, so for task 1 here, what our job is we're supposed to design we're supposed to be designing the decision logic for a smart home thermostat system. The thermostat constantly monitors the current temperature inside the house and compares it to the temperature set by the homeowner. If the house is colder, than the desired temperature, the system may attempt to turn on the heater. However, some homeowners enable an energy saving mode that limits heating to produce or to reduce energy usage. When energy saving mode is active, the heater should not automatically turn on, even if the house is cold. If the house temperature is already at or above the desired level, the heater should remain off. Your program should evaluate the current temperature, the desired temperature, and whether the energy saving mode is enabled, and then print the correct message describing what the thermostat decided to do. Now, from this, you could pick out that you need to have the following variables. A current temperature variable, that would be a float because temperatures can be, 67.2 degrees or, those kind of items. So you know the type would have to be a float. And then we are looking now at the desired temperature. That also we know is going to be a float. But there was a part in here that was talking about the heater should not automatically turn on even if the house is cold. If the house temperature is already at or above the desired level, the heater should remain off. We're supposed to evaluate that energy saving mode. So it's either on or off. Whenever you read that, you would know, okay, that might be a Boolean. Now, the next part is using conditional statements to follow these rules. If the current temperature is lower than the desired temperature and energy saving mode is off, print heater on. If the current temperature is lower than the desired temperature and energy saving mode is on, then we're going to print out energy saving. So we could have deduced that from this one scenario. Then we see otherwise print heater off. Only one message should be printed. This is kind of the structure of this whole entire scenario. So now when we get to the pseudocode, and we store the current temperature, we have our variable, we have our Boolean variable either being true or false. If the current temperature, so we're looking at our if statement, if the current temperature is less than desired temperature, so if that variable is less than this variable, and so we're also looking to make sure the energy saving mode is false. Then we print heater on, else if the current temperature is less than desired temperature and the energy saving mode is true. So we print out the energy saving mode active, else print heater off. And then these are some of the test cases that you'll use once your code has been written. So looking at this code that I have here, the first thing I have is the current temp. Let's go ahead and use test case 1, 65.0. So we're going to go that to be 0. And then the desired temperature here is going to be 70. Okay, we got that. Now we want to make sure that we set the energy saving mode to false, which we do. Now here we turned our pseudocode into real code. So here we have, if the current temperature is less than the desired temperature, and we're using our and here, and means this has to be true and this has to be true for us to be able to see this heater on. So if this is true and the energy saving mode is equivalent to false, which we know at the present it is, then we know it should print heater on. Let's look at that test case. It says it should be heater on. Then we have elif. Current temperature is less than desired temperature and the energy saving mode is on, meaning true. Then you would say energy saving mode active. Else, heater off. Simple structure from a scenario-based question here. So now let's go ahead and run this. All right, so we do see heater on. So we know that that is correct. And what your job is now is to make sure that you go through each of those test cases and test out to make sure that your code works. Now, the next part of this would actually be part two. So now we're going to get into that really quick. So for part two here, what we're going to look at is we're focusing in on the online store checkout validator. So here you're building the checkout decision logic for an online shopping system. When a customer attempts to purchase an item, the system must determine whether the purchase can be completed. Each item has a price, and each customer has a certain amount of money available in their account. Some customers are premium members and receive a discount on their purchase, while standard members do not. The system must first determine the final price of the item after considering any applicable discount. If the customer has enough money to cover the final price, then the purchase should succeed. Otherwise, the purchase should be rejected. Your program should evaluate the item price, the customer account balance, and their membership level, then print the appropriate results. Now, based off of that scenario, we can deduce we need the item price, which is going to be a float because the price of anything isn't going to be just $5, $6. It could be $5.22. So we use the float type. The account balance, the same thing. You could have $100.22. That is in the account balance. Now we're going to look at the membership level. Now for this, we understand that the members can be either standard or premium. Some customers are premium members and receive a discount on their purchase, while standard members do not. So we know that this is either going to be a string, standard or premium will be assigned to that membership level. Now, the next thing is we want to apply these specific rules. The premium member is going to receive a 10% discount. The standard member is going to receive no discount. So if the account balance is greater than or equal to the final price, then the purchase succeeds. Otherwise, it doesn't. And these are the messages that we would print. Exactly one message: purchase successful or insufficient funds. So in this case, when we look at the pseudocode, we know we're going to have three variables: price, account balance, and membership level. We know here for our if statement, we're going to check the membership level. If the membership is premium, we're going to calculate that 10% discount first. Else, final price is item price. Then the next part of this, we want to check to make sure that their balance is greater than their final price. If it is, then purchase successful, otherwise insufficient funds. And then below here, we have our test case. So let's go ahead and look at one of these test cases here. So what we'll do is we'll look at premium and insufficient funds to test out both the premium and standard part as well as insufficient funds. So when we look at this, what I'm going to do is set my item price to be 50, which is already there, and then set my account balance to 40. Now, the next thing I want to do is set my membership level. I already have it at premium, and so I'm keeping it there. Now, the next thing I want to do is I want to check if the membership level is equivalent to premium, which we did. Now we're going to say final price equals item times 0 0.9. So we get that kind of 10% discount process there. Now, then we have else final price equals the item price. So what we're doing is we're assigning the item price to the final price if they are not a premium member. Then here we say if the account balance is greater than or equal to the final price, purchase successful because we know that if the person has $50 and the price is $50, that it's successful. If it's $50.20 that the item is, then it should be insufficient funds because they only have 50 items. Let's go ahead and print this out and see what happens. From our test case, we know that it should print insufficient funds. And we see here that we do have insufficient funds get printed out here. But let's go ahead and actually test out the standard member here. So we're going to go ahead and change it to standard, and we're going to put 50 for everything. All right. We know that at least from this 50-50, we should get purchase successful, and we do here, purchase successful. So that worked out well. Now, the next item on our list as we move past task 2 is task 3. Now, task 3 is focusing in on a secure login system. You are implementing a basic security check for a login system. The system keeps a list of users who are authorized to access the application. In addition, some accounts may be temporarily locked due to security concerns. When a user's attempt to log in, the system must first check whether the account is locked. If it is locked, access should be denied immediately, regardless of who the user is. If the account is not locked, the system should then verify whether the username appears in the list of authorized users. Only users who are authorized are not locked should be allowed access. Your program should evaluate these conditions and display whether access is granted or denied. Now, for the first thing from that, we should deduce we want to have a username, which is a string. We want to have a list of strings, which is an authorized user list. And then we want to have account locked being Boolean, either true or false, right? Then we want to apply the logic in the correct order. If the account is locked, we're going to deny access immediately. If the username is in the authorized user list and the account is not locked, here we're using our not operator, we're going to allow access. Otherwise, deny access. Then we're going to print only one message, access granted or access denied. Now, based on that code, we look at the pseudocode and we see we have the username. We're going to have a list of authorized users. And we're also going to have store account locked status, either being true or false. Now, the next thing we're going to look at is our if else statements. If account is locked, print access denied. Else if username is authorized, user list, access granted. Else, access denied. So we're seeing our kind of logic here structured a little bit more in a more efficient way. So now let's look at the code. So here we have our username. I type in admin here. So let's look at our test case. We're going to use admin here, and we're going to have authorized users being admin and staff. We're going to get rid of manager. All right, admin and staff. Now the next thing we're going to have is the account is locked, which is false. So we're going to leave that as false. But when we look at our if logic here, if account locked is equivalent to true, which it's not, then we say access denied. So we should not see access denied. Elif, the username, so it's going to bypass that and go to elif, the username in authorized users. So is admin inside of this list? And we're using our in membership here. And we're using our list to check if this is in our list. So you'll notice that we don't necessarily have to deduce this by saying not equals. We can just use our in membership and get our list. Then it says access granted. Otherwise, if none of these conditions check out, then it's just denied. You don't get access. Let's go ahead and run this. So here we see access granted, and that goes hand in hand well with our test case. Now, I want you to try your hand at doing all of these other test cases and making sure that your code runs well with that. Now, we've already went through the task 7 in class, but just for the sake of completion of this video, this is task 7 where we're looking at creating our Dungeon Gate game. We have if the user has a key, if they've opened some door or opened another upper or where is it? If they open the dungeon, then we have their health, which is a number, and inventory, which is a list. And we're just going to say if their health is less than 0, we're going to print game over. If the player has the key and the dungeon is open, then we're going to print dungeon entered. Otherwise, we're going to print access denied. If the ring exists in inventory list, also we're going to print bonus unlocked. So in this case here, I did have a pseudocode available. So we have our 4 different variables that we have. We have 2 different if statements. We have our if-else statement, and inside of the else, we have another if-else statement. And then we have our if statement to check to see if that ring is inside of the inventory list. And then we're going to print out bonus unlocked. So in this case here, we have several test cases that you can test out to make sure that your code works well. So in this case here, we know that we have has key, we set it to true, is open, we set it to true, health is set to 10, and then we put inside of inventory the ring and a potion. So we should get dungeon entered and bonus unlocked, which we do as we run it. But we have now ring and potion. So the first thing, if health is less than or equal to 0, health is at 10, so it's not. So it doesn't say game over. So instead, what it does, it goes to else. Now we're in else, and we're checking is if has key, which is true, and is open, which is true. So true and true means yes. So we say dungeon entered. We are going to print that out. Else, access denied. So if one of these is even false, it should be access denied. Now, then we have later on, if the ring is in inventory, where we're using our inventory list and our in membership here to check if this value is inside of the inventory. Remember, Python is case sensitive. So if I were to run this, it won't say bonus unlock anymore down here. Oops, one thing. All right. It actually says, let's zoom in a bit. Dungeon entered, and it removes bonus unlocked. And that's because ring needs to be lowercase. Now it says bonus unlocked. So this was just the last task, the last part. Again, we went over this in class, so this one should be fine. But this is the full works of class activity 05. Please let me know if you have any questions whatsoever, and I hope that you have a good rest of your day.